Okay, so how about this one right here? A flower is 4.5 centimeters wide and has a leaf of 7.2 centimeters long. What is the ratio of the flower width to the leaf length? What goes on top in that ratio? Flower width to length. It's a ratio, so it's 4.5 over 7.2, which is 5 over 8. How'd she get 5 over 8? I don't know.
Yeah, how'd you take that?
I don't know, that's what she has written down, but I don't agree with that, so I have to think about that one. All right, let's move on to direct variation. Write a direct variation equation that has the given point as a solution. First of all, a direct variation equation you will see written like this in the book, y equals ax. They call that direct variation. Why they use a, I don't know. It's really the same as slope. But what part of this equation is not here? Because it's what? Zero. It's always zero. Always, always. So you just don't, we don't write it when it's zero. Okay? Any direct variation graph is going to go through 0 at the y-axis. So what we need to write the equation is you need A. So if we start with this, what are they giving me here? How can I come up with the equation if they only give me 1 point?
It goes through 0.
You know it's 0, 0, but they also gave you what? X and Y, right? And all we need is A, so we just plug it in. Y equals AX, we plug in.
How neat is that? That's not.
How neat is that? That's right.
That's not neat. I have to say that.
Divide by -3, divide by -3, A equals 3. Now, I'm almost done. I have to write the equation. So I would write it as y equals 3x. That's the direct variation equation. Okay? All right, let's do this one. They gave me x and y, so I just plug it in because all I need is A. I need to see what the constant of variation is. That's what A is. It's the constant of variation. How much y varies by for every x. It's like finding the slope. Divide by 6, divide by 6. A equals -1/3. Y equals -1/3 x. So which one's going up and which one's going down?
The one on the right is down, and the one on the left.
Okay, here's an extension question. If this is going down and it goes through 0, 0, what 2 quadrants is this graph going to go through?
1 and 4.
Oh, I totally forgot.
2 and
Close, close.
2 and 5. No, 2 and 2.
2 and 3. 2 and 1.
2 and 1 and
2 and 4. 2 and 4. Okay, do you remember the quadrants?
no.
This is 1, 2, 3, 4. If it's a direct variation equation, we know it goes through 0, 0, and if it's negative, it's going to go down through 2 and 4. Okay? You don't really need to know that, but sometimes it's good to bring that stuff up from the past. Yeah.
A shortcut of finding the A
What's that?
is divide the Y, or divide the X by the Y. No, the other way around.
No, he did it right.
You divide the X.
Yeah, exactly, Noah. And I was going to get to that. Look, if you take this and you divide both, it's y by x. So you would get this. A equals y over x. And that's what we did here. -2 divided by 6. Yep, that's exactly what you're going to do. Okay? All right, turn it over. Now, you guys, don't shy away from this stuff. It's not that bad, okay? These story problems, just read it to yourself. Hooke's law, physics, or I don't know what that is, states, I think it's physics, states that the distance D of a spring stretches, varies directly with the force F that is applied to it. Okay, so we have D and F, yeah? What depends on what in this situation?
D depends on
The stretch depends on the force, right? On the force applied. So which is X and which is Y?
Y is
Which one?
Oh, maybe it's opposite.
Stretch is Y, force is X, correct?
Yep.
Because you can control the force, and the stretch will depends on the force. So I would write it like this. Suppose a string stretches 15 inches when a force of 9 pounds is applied. Write an equation that relates D to F. So this is D. I'm trying to come up how to do this. This is D and this is F. So it would be D equals AF, right? The distance depends on the force, right? Distance depends on the force. Okay? Do y'all see that?
Yeah.
So then they're saying the distance is 15 inches. The force is 9, so I got to find the direct variation. Divide both sides by 9. And A equals 15 over 9, which is 5/3. And then I write my equation. The distance equals 5/3 of the force. That's a direct variation equation right there. Predict the distance that the spring will stretch when a force of 6 pounds is applied. So they're giving me F here. So how do I do this problem?
Divide by 3.
Just plug in 6 for F. Now you can put this over 1 if you need to. Doesn't really matter. 6 times 5 is 30. Divided by 3 is 10. 10 inches. 6 pounds of force is applied. The distance is 10 inches stretch. Okay? All right, here's the other thing you got to do. The dimensions of 5 rectangles, each with an area of 24 square feet, are given in the chart. Tell whether length and width show direct variation. If so, write an equation that relates the quantities. So, on the side here, if you have direct variation, you could also write it like this. You need to know that the constant of variation, that's what this is called, the constant of variation, is basically just the slope, is equal to y divided by x. In order to decide if this shows direct variation, y divided by x has to be the same for every point in the chart. To show direct variation. So I'm just going to put to show dv. Y divided by x has to be the same for every point in the chart. If it's not a constant of variation, it's not direct variation. So let's just try a couple points. This is x, this is y, correct? If I do this, y divided by x, 24 divided by 1, what do I get for this one? 24. If I try another point, doesn't matter which one, 12 divided by 2, what do I get? Oh, wait, we got a problem. These numbers are not the same. Therefore, this does not show direct variation. If you did another one, just for the heck of it, okay, 8 divided by 3, 8/3. Again, they're not the same. Not the same. No direct variation. Okay? Sometimes you'll get some charts that'll be like a very few decimal points apart, and you could probably say, yes, that does show direct variation, but most of the time it'll be pretty obvious.